In the final example, example 6, what we're going to now look at is if we can find the polynomial now given the zeros. So what did you notice about the complex zeros and their factors in the previous examples? No matter what, when you have an imaginary, you'd always have its counterpart, its negative. So you always have the conjugate pairs. So complex zeros always occur in conjugate pairs. If you got 2i, you'd have negative 2i. If you have I, you'd have negative I. If you have negative 5i, you'd have positive 5i. And the reason for that is because of the plus or minus when you're solving an equation, solving for the zeros. So in this case, complex zeros always occur in conjugate pairs. So if you have a plus bi, whether I give it to you or not, a minus bi would always exist. So let's look at this example. Find a polynomial given the degree and zeros. So this says a degree of 4 with only the zeros 4i and I. And so what you may be thinking is there's only 2 zeros. Nope, they come in conjugate pairs. So if I have 4i, that also means I must include negative 4i, and I also have I, so I must include negative I. Okay, great. Now if I have this degree 4, let's see what happens. All right, we have our zeros, so let's put them in the factor form. X minus 4i, x plus 4i, the 4i's first, then I have x minus I, and x plus I. Great. Let's FOIL it all out, and we'll see if we can come up with the function. FOIL the first two. X times x is x squared. X times 4i is 4i times x. And then negative 4i times x is a negative 4i times x. You'll see that those will cross off. And then right here, this is a negative 16i squared. I'm going to clean those up in just a second here. The other ones over here, x times x, that's x squared. This is plus I times x, negative I times x, and negative I squared. Don't forget what I squared equals. We're going to take care of that in just a second here. I got the square there. Those are gone. They cancel each other out. I'm left with x squared. I squared, remember, just throw it up here. I squared, just I squared. I squared is equal to negative 1. So negative 16 times I squared is just negative 16 times negative 1, which is a plus 16. And the same thing over here. I'll clean this up. That's gone. I have x squared. Negative I squared right here is just a positive 1. And now if I FOIL those out, those two out, my final step. And now, x squared times x squared is x to the 4th. X squared times 1 is just x squared. 16 times x squared is 16x squared. 16 times 1 is plus 16. Combine like terms, x to the 4th plus 17x squared plus 16 is a final answer. There is the function or the polynomial I was looking for with those given zeros. All right, so I have the degree of 4, and notice it says degree of 4. I have a degree of 4. That's my highest exponent, a degree of 4, with the given zeros. They only gave me 4i and they only gave me I, but I included the conjugate pairs of those, negative 4i and negative I. Do not forget those. That is one confusion that students sometimes have, is they forget the conjugate pairs when there's imaginaries. That is it for 3.5. If you have any questions, make sure you ask me, Mr. Hall, or you ask Ms. Zara.